So just wanted to reiterate, thanks everybody for coming out this evening. So I'm going to give just a little bit of a presentation about what is on the table, so to speak. It's a permit modification that is for one of the waste management units at Hanford, and it's the PUREX tunnels. So I'll talk a little bit about the history of the tunnels, what the permit modification is. The Department of Energy has asked for something called a temporary authorization. I'll talk about what that is, and then our decision-making process and timeline. And then we've got some technical information that a contractor for the Department of Energy, CH2M Hill, will be giving, and Dan Wood will give that presentation. A little more technical information about why they have asked for a temporary authorization. But hopefully this will all become clear shortly. So these are just some visuals about the tunnels. You all probably heard approximately a year and a half ago, tunnel number 1 partially collapsed. It was an all wooden structure, and part of the roof collapsed. And at that point, the decision was made, it was an emergency to try to stabilize the tunnel. The structural integrity of the tunnel had already been compromised by the partial collapse, and so under the contingency plan of their permit, it's a permit under the Resource Conservation Recovery Act, and that is all about the safe management of hazardous waste, but also hazardous wastes that are mixed with radioactive wastes. So the permit, there's a contingency plan of what do you do in an emergency, and under that contingency plan, we allowed them to grout Tunnel 1. Now Tunnel 1, in the photo on the left, you can see there's a little arrow, it says tunnel number 1, that's covered with a cover at that point in time. That is approximately 358 feet long, and the sort of long strip that goes along the right side of that is tunnel number 2. Tunnel number 2 is approximately 1,680 feet long, and it is 10 times the volume of tunnel number 1. These are artists' depictions of what's in those tunnels, and they've actually, Department of Energy has gone in with video cameras and lights and has taken photographs of what's in those tunnels and video of what's in those tunnels, and this is basically a rendering of that. What's on the left is what's in tunnel number 1, and tunnel number 2 it's long, so they broke it up into 3 to fit this picture, but that's a rough approximation of what's in the tunnel. It's used equipment from the PUREX facility, and the PUREX facility was where they extracted plutonium from irradiated fuel rods. So they took irradiated fuel rods from the 9 reactors, took them over to these large canyon facilities, and PUREX Canyon is one of those. And then from that, they put them in essentially large baths of chemicals, the size of football fields, and then dissolved the fuel rods, and from that they extracted plutonium that they then made into hockey pucks, and that's what was put on bombs and things. So the PUREX facility made, I think something like 60% of the nation's weapons-grade plutonium. It was extracted at this facility. So the equipment from all that processing was highly contaminated, highly radioactive, and the way they disposed of it was they built these tunnels and put in rail cars on a slight decline, and they put the equipment on the rail cars and put them into the tunnel and then closed the tunnel up with these water-filled steel doors. So,
what year did they do that?
They did that in. So tunnel number 1, what luck you asked that question. The tunnel was constructed between 1954 and 56. This is tunnel number 1, the shorter tunnel that collapsed last year. It was filled between 1960 and 1965, and again, it's failed equipment, and there's 8 rail cars worth of failed equipment there. So tunnel number 2 was built in 1964, and it's a different kind of construction. You can see this is a picture during the construction. It was filled between 1967 and 96, and again, it's failed equipment, but this time there's 28 rail cars with the failed equipment on it. You notice it's a different kind of construction. They decided to make something a little sturdier, and so they did this Quonset hut using essentially corrugated metal. But while they were building it, the tunnel collapsed. And so they went back and essentially reinforced it. And you can see in this photograph, they reinforced it using concrete beams. And these right here are the wooden molds that they poured the concrete into. So that's the construction of tunnel number 2. So what waste is in the tunnels? The types of equipment you can see up on the left side, it's concentrators, piping, centrifuges, dissolvers, containers of waste from the 324 and 325 buildings, which is highly radioactive waste, and some liquid waste tank cars, but under RCRA they had to be emptied before they were put in the tunnel. So the RCRA regulated waste, again, that's the Resource Conservation and Recovery Act, all about the safe management of hazardous waste and hazardous waste that's mixed with radioactive waste. There's mercury, lead, silver and silver salts, chromium, cadmium, barium, and mineral oil. Other wastes include, this is more of the radioactive materials, uranium, plutonium, cesium-137, strontium-90, iodine-129, ruthenium-109, and ruthenium-rhodium-106. So, when the tunnel collapsed last May, the day after it collapsed, the Department of Ecology issued an order to the Department of Energy, and it said, we need you to do 3 things. Thing 1 was, you need to do an integrity assessment of both tunnels, because one hadn't been done for decades. And so that was thing 1. Thing 2 was, you need to come up with some corrective actions. You need to identify ways in which you're going to stabilize both the tunnel structure as well as stabilize the waste in those tunnels so that at least it's safe for people in the community and also the workers in the area. And then the third thing they needed to do was, once they identified the corrective actions and we were, at least gave a preliminary okay from the Department of Ecology, they needed to then submit a permit modification so that their permit accurately described these corrective actions that they were going to take, or, that they're going to take. So the structural integrity evaluation, that was thing 1 we asked them to do. It said tunnel 1 presented an extreme collapse hazard. And so they began, under the contingency plan of their permit, as I mentioned earlier, they began stabilization. And actually, initially, within, I think it was 36 hours, they had filled the hole in with dirt to at least sort of, to cover up the hole, shield the area. But then they went ahead and starting on, I guess, ending on November 11th, they went ahead and poured grout into that tunnel. And that's 358 feet long, the shorter tunnel. And that took 521 truckloads of grout, about 4,434 cubic yards of grout was put in tunnel number 1. It is now stabilized, and the grout is acting as shielding material. So tunnel number 2, the integrity assessment that was done said the existing tunnel 2 structure presents a high potential collapse hazard. So it wasn't extreme, as in the case with tunnel number 1, but it was a high potential collapse hazard. To grout that tunnel, to stabilize it using grout, will take 4,300 cubic yards of grout, approximately 5,000 truckloads. So the draft permit modification, which is what we're asking you all to comment on today, this is what the permit process looks like. They propose the permit modification, so we want to modify our permit to reflect that we will stabilize the waste on an interim basis using grout. So they propose that, and this kind of permit modification, because it's a big deal, it's a lot of work and a lot of effort, there's 2 public comment periods associated with it. There's one when the permittee, the Department of Energy, submits the proposal to us, and they do a public comment period at that point in time, and that's the 60-day public comment period. So the Department of Energy did that in February to April of this year, and they held a public meeting in Richland in March. So then the second public comment period is what's going on right now, and that comes about when the Department of Ecology has looked at the permit modification and made sure we've got all the information that we need, and then we go ahead and we propose the permit modification that we think we should adopt, and we put that out for public comment. So that's what's happening right now. It's a 45-day public comment period. We put this out on August 13th. The public comment period runs until September 27th. And we had one hearing in Richland on August 27th, and then this is our second hearing here on the west side of the mountains. So after the second public comment period closes, what we do is we evaluate all of the comments, and then we issue a formal response to comments document. And this gets to a little bit what Hideo was saying about what's recorded and what's not recorded. Anything that you all provide orally during the hearing will get recorded by the court reporter, and then we, in our response to comments document, respond to those comments. Anything you ask during the question and answer isn't going to be recorded, and then we won't be responding to it in our formal response to comments document, but we will respond verbally tonight. So just want to make sure that that distinction is clear. Ooh, I've got the red light. Oh no. And then once we've responded to comments, we make a decision as to whether to go ahead and issue the permit modification. Once we make that decision and put it out, there's a 30-day appeal period, and then after the 30-day appeal period expires, if there's no appeal, then the permit becomes, the modification becomes effective at that point. So these are the various parts of the permit that are being amended by this proposal to stabilize the tunnel with grout. And so this is what the permit modification proposes. It proposes an interim closure action, which is to fill Tunnel 2 with engineered grout to help mitigate potential threats to human health and the environment. It's to make sure both that the tunnel structure is stabilized, but also that the waste inside the tunnel is safely stored until a final remedial decision is made about the waste in that tunnel. So under the tri-party agreement, not only is this a RCRA facility, there's also a larger Superfund operable unit that contains all these facilities, the PUREX Canyon facility as well as the PUREX tunnels. The tri-party agreement right now has a deadline for the start of the process to decide what the final remedy will be for all of these facilities and the waste in them. And the first deadline for that under the tri-party agreement is they're going to submit a remedial investigation feasibility study work plan to us in 2020. So there is a separate Superfund process that will happen that will evaluate the waste in all these facilities and then come up with alternatives for how that waste can be cleaned up for a final cleanup. So this is an interim stabilization activity, and then down the road, the CERCLA Superfund process is what will decide the final fate of the waste in those tunnels. Okay, so the one condition we have put on the Department of Energy throughout is whatever you choose for interim stabilization cannot preclude having a different final remedial decision at the end of the day. And the Department of Energy has committed to us that they can with diamond saws cut up the grout, and they have mapped what's in the tunnels well enough that they can safely cut the grout into pieces and remove the waste from the tunnels if that is the selected final disposition. So, all right, let's see. So the State Environmental Policy Act, we issued on August 13th a determination of significance under the State Environmental Policy Act. And, but we also then adopted a portion of an existing EIS that the Department of Energy did. It's called the Tank Closure Waste Management EIS. And it specifically evaluated the environmental impacts of grouting these tunnels, because that was something the Department of Energy has been contemplating. So we went ahead and adopted that as part of our SEPA process. But once we get to final closure of the tunnels, then we'll need to do further environmental analysis of an array of different alternatives for that waste. So there will be alternatives evaluated when the final remedy is chosen for the tunnels. Okay, so on July 12th, the Department of Energy submitted what's called a temporary authorization request. And that basically says, that we have discretion at the Department of Ecology to allow them to go forward with the work that they want to do under their permit modification, but ahead of the public comment period. So go ahead and do it before the public comment period ends. So they've submitted that request to us, and part of the reasoning for that was they got a chance to go get some cameras inside the tunnel and take a look with video and cameras, and they saw that there was corrosion on a lot of the metal parts in one end of the tunnel. And that caused them a lot of concern. And so they thought it would be prudent to go in and grout early, get the grouting done before winter comes. If we follow our normal process and don't grant the temporary authorization request, don't let them grout early, then likely the permit won't be effective until mid-November. And so that would put the bulk of their grouting work in the winter. So that's part of the reasoning. And Dan Wood is here to talk a little bit more about the temporary authorization request and their thinking behind that. Speak up? Okay, sorry. Okay. Okay, so what we asked at the Department of Energy, what we asked them to do when they issued the temporary authorization request was give us more information about what does the corrosion mean? You know, how do we know that it hasn't been there for decades, and does this mean there's a higher likelihood of a collapse in the near term? So the department gave us some additional information, and we said, based on that, you can go ahead and start putting in equipment and infrastructure, but it's at your risk, understanding that as we move forward with the public process, if the decision is made by ecology that we don't think it's appropriate to start grouting early, or that we don't think it's appropriate to grout, that you've gone ahead and placed this equipment at your risk. And the department has gone ahead and done that. But we also said, as part of that letter, we want some quantitative information from you. You've done some numbers on the integrity assessment. We'd like you to update those numbers with additional information and assumptions based on the corrosion that you found. And so the department has done that, and Dan will talk a little bit about what those numbers indicate. Okay. So tonight's hearing, the purpose is explain what the action is. Hopefully you understand it's all about grouting tunnel number 2, to answer your questions and then receive your comments. So I'm going to go ahead and hand it off to Dan and pull up his presentation.
Good evening. My name's Dan Wood. I'm the Chief Operating Officer for CH2M Plateau Remediation Company. We are a company that is responsible for the safe maintenance and protection of a large number of facilities at Hanford, including the PUREX facility and the tunnels associated with it. I'm going to go through the background but focus on recent investigations, what we found during the remote inspections, show you how that affects the calculations that previously showed the tunnel at risk, talk through 2 case studies to give you some examples of where structural corrosion has a significant impact, talk about the nuclear safety perspective, and then close with 1 slide and speak on the diamond wire saw technology that has been used in decommissioning around the world. The tunnel, as you saw in Alex's slide, did collapse. You can see that in the top right during construction. It's basically a World War II Quonset hut type design. I'm going to point out 2 things that I want you to pay attention to on this slide. The first, at the top of the arch, you can see a small connection. I'll show you a highlight of it. It's one of the overstressed points on this structure. The other has to do with the redesign. The concrete arches were put on to strengthen the top of the tunnel. And to keep it from falling in between the arches, they ran I-beams, the technical term's a whale beam, that are anchored. And these anchors are another area of concern. So I'll show you those. We'll talk about those later. You heard Alex talk about the inspection that we did. We were able to go through the risers. The risers are 30-inch diameter. Think of a round trash can. Goes down through the 8 feet of soil that's on top of the tunnel and allows us access. So we were able to pull the shield plugs and go in. We started near the entryway of the tunnel where it's empty, and we found very little to no corrosion. The inside of the tunnel actually looked pretty pristine to be as old as it is. But as we made our way down the length, particularly down on this end, and for decades this filtration system ran, so it's a fan drawing air, and the bottom of the tunnel is just dirt. Okay, it's not concrete, it's just dirt, it's a railroad bed. And so moisture was drawn the full length of the tunnel. And what we found is we got to about riser 14, we started seeing surface rust. And I'm going to show you pictures from riser 16, which are why we're concerned. So these pictures, this is the well beam that I mentioned. That long I-beam, there's a whole series of them that run the full length of the tunnel. Here you can see the connecting rod that goes up into the concrete arch overhead. And you can see the amount of rust that has us concerned. This picture if you look at this detail, and if you're familiar with cars and structural things, we're looking at a galvanized washer. It wasn't called on the drawings to be galvanized, but clearly that's what that white corrosion is. And unfortunately, dissimilar metals put together corrode a little faster. So the threaded components are certainly of concern. This slide tries to answer ecology's question about the quantitative impact of the corrosion. The top section refers to those bolts that I was just pointing out, and the graph on the left shows the load carrying capacity of those bolts. So one of those bolts, right out of the manufacturer's catalog, holds 38,100 pounds. But as you remove material, in the sense of rust, it weakens. Now, I've picked, in this example, a 4 mil amount of corrosion. 4 mils is the thickness of a typical sheet of paper. So think about how little corrosion that is. That removes 1,000 pounds of carrying capacity on one of those bolts. So for a full 4-bolt connector, that's 4,000 pounds lost. Now, of concern are the threads. The surface of the bolt itself is not our concern. Our real concern is the threads. Now, these pictures to the right are not from the tunnel. They're from a bridge, actually. And you can see how the threads have corroded significantly here. Now, the other thing I want to share with you is we're looking at the parts of the tunnel from the inside. I don't know what the corrosion is on the outside of the tunnel in the dirt. Okay, but in this example from the bridge, the bolt looks fine on top, and the young engineer who was doing the study, literally, she could pick it up. The bolt didn't exist underneath. So that's one example and one component of concern. The second is this splice that I talked about. This is a picture of that splice actually failed when the tunnel collapsed during construction. So this picture is from the early 1960s. And this finite element analysis basically is simple to describe. The red is bad and the green is good, right? Of most concern is the weld here. And you see in this connection, that's that weld joint broken away from the I-beam below. And again, as the rust increases, the load carrying capacity of this joint drops. And in this case, instead of pounds, there's a demand to capacity ratio shown. Basically, if the number is greater than 1, there's more demand on the joint than it's capable of carrying. And that was used in the earlier analysis, so we show it here for comparison. The early analysis showed this component down around 1.09. If you take into account even a moderate amount of corrosion, you quickly get up to a 1.45 type overload, 45% over its capacity. So if I go back to the original study that was done last year at the request of ecology, you see loadings here using that demand to capacity ratio. Now there are lots of components and parts in the structure, but we picked out ones to highlight that were overloaded. Now the one that has us most concerned today is the arched rib beam splice. That's the one I was just talking about with you. That with just a 32nd of an inch, so 6 or 7 thicknesses of a piece of paper gone from that weld, you get a 1.45 demand to capacity ratio. There are several other components, such as the concrete arches. We have no reason to believe that's changed. However, I talked about the threaded anchors, and they're very suspect. Okay? I don't know how much corrosion is on them. I only know from the photos. I wouldn't want to be standing on something that looked like that. Real quick, I want to talk about two case studies. I'm going to talk about a nuclear safety perspective, and in the past, we've considered a collapse of the tunnel to be a localized event, much like it was on Tunnel 1. One connector would fail, that would be it. We would impact maybe the waste right below it, and that would be the end of it. There's a term called a progressive failure. Somebody might have called it a domino effect or a zipper effect, where when one structural component fails, the load has to be picked up by the rest of the structure. If the component beside it can't carry it, it'll fail. An extreme example of that is this structural steel bridge. This is I-35 West in Minneapolis, and you may recall that it failed. What was interesting about this bridge, it was 40 years old. It was known to be overstressed to today's standards. It had corrosion, as you can see in the photos there. And they were working on it at the time, but they were working on trying to repair the potholes. They were not working on the structure. 13 people lost their lives, very unfortunate. The second case study has to do with snow loading. Snow loading is some of the heaviest loads that an outdoor structure carries in our environment. This particular paper that we looked at was from the Spokane Coeur d'Alene area some years back, about 10 years ago. Had a big snowfall. They had well over 100 structures fail, and the Structural Engineering Association in that area did a case study, and what they found is not a single structure had more snow on it than designed for today. However, 95 of them failed. And they failed because they were built to older standards. They may have had corrosion or been modified. They may not have been built with all the components properly. It's a whole spectrum. There was one case where the trusses, and this is on a local store in Spokane, actually collapsed. The snow line shows you the start, and then it just ran the whole length. So it was recorded as one of those progressive failures. If we think about it from a nuclear safety perspective, we talk about risk in terms of the likelihood of a failure. Is it going to happen tomorrow or in 100 years or 1,000 years? And we talk about it from consequence. How severe will that failure be? In the past, we've considered the failure of the Tunnel 2 unlikely with only a low severity. Given the results of the visual inspection and the updated structural analysis, we now believe we have to anticipate this failure. And if you're into probabilities, that means it's less than a 1 in 100 years, all the way to it's going to happen. And it's now a moderate severity because of the potential of impacting multiple waste packages in the tunnel. The pictures on the right are this same artist's rendition, a young engineer modeling the tunnel, but you can see the skeleton of the framework and how it might turn loose in a collapse. So what do we know? We know structural failure has to be anticipated today. I can't tell you if it's tonight, if it's tomorrow, if it's next week, if it's a year from now. I can tell you that the corrosion is there and has reduced the strength of the structure. I can't tell you exactly how much. The tunnel's environment's too hazardous to go into and try to take measurements or anything else. So the full extent of that corrosion and what it's doing to the structure is unknown. We do know that a failure could put the workers in the area, the public, and the environment at risk. These components are highly radioactive, and a failure could rupture one of the waste containers or pieces of equipment and create an airborne release. One last slide on diamond wire saw cutting. Grouting waste is a very known and common way to respond because it provides shielding and it locks down the contamination. Throughout industry, whether it be nuclear industry or non-nuclear, this technology of using a cable that's got embedded beads of man-made diamonds in it is a way to solve very dense and strong concrete and metals. So this saws right through the concrete and the rebar. You see it here in these pictures being used at a nuclear site for the shield wall around the reactor. It's been used in a lot of configurations. This is not a new technology, it's a very well-known one. And as Alex said earlier, we now have a mapping of the entire tunnel so we can saw between the various rail cars and the waste components if that's what we decide to do in the future. Thank you.
Okay, at this time we have two other people who are going to give short presentations. One is from Heart of America Northwest. Go ahead and set your slides up. Yeah, go ahead and set that up and tell me when you're ready. So the first one will be by Jerry Collette with Heart of America Northwest, which will be followed by Tom Carpenter with Hanford Challenge. And as soon as he gets his PowerPoint slides up, he will start.
I'm Jerry Paulette with Heart of America Northwest, and I want to start by thanking all of you for coming out. It's been 4 or 5 years since the Department of Ecology, U.S. Department of Energy have agreed to do any public meeting on any Hanford decision outside of Richland. And so thank you for being here at the first public hearing in 4 or 5 years and offering your comments. And thank you for Ecology for holding this hearing. It's been a struggle since the Energy Department has not been wanting to go around the region and answer any questions. Tonight's number one word, I would say, is irony. And this is from King 5 Television's award-winning investigative reporting. For 20 plus years, citizen groups and the Hanford Advisory Board have been saying these tunnels will collapse and the Energy Department should be ordered to remove the waste from the tunnels. And 2 years ago, the Energy Department would have scoffed at its own presentation here tonight, saying that the tunnels are at high risk of collapse. In 1980, 48 years ago, the Energy Department commissioned a study warning that the tunnels would collapse. In 1991, the Energy Department made a formal commitment to the to Washington Ecology that it would either remove the waste from the tunnels by 2001 or it would do a new structural integrity study. 2001 came, Ecology forgot about it, the Hanford Advisory Board, citizen groups did not, and nearly every year since we've said, get the waste the heck out of those tunnels. But the Energy Department has always said, we actually want to grout the tunnels, we never want to remove the waste. And now, lo and behold, Tunnel 1 collapsed, and they've got the darndest convenient excuse for grouting the tunnels. And they're so eager to do so, they don't want to wait to review your comments, and they want permission to just go ahead. And so we urge you to say no to going ahead before they've considered your comments. Why? First off, they actually don't know what's in the tunnels. And they never will once they grout the tunnel. It is impossible to ascertain and legally meet the legal requirements for knowing the chemical wastes in these tunnels. What came out of the PUREX plant included wastes that are known to self-concentrate and explode, in addition to being high-level nuclear waste and plutonium wastes that are only legally allowed to be buried deep underground in a geologic repository. And since time is real short here and we're at 4 minutes, I'm going to say the State Environmental Policy Act requires consideration of reasonable alternatives to stabilization. You didn't see any presentation about that tonight because they have failed to do any study under SEPA, the State Environmental Policy Act, to show you and the decision makers what we've been assured by numerous experts, that there are many alternatives to grouting the full tunnel in order to stabilize it until you remove the waste. Therefore, we're saying, ecology, issue an order saying that the waste will be removed in 3 to 5 years. If that is in the order, we bet that the Department of Energy will find better and cheaper and faster alternatives that allow for proper disposal of the waste when retrieved and identification of the waste in order to retrieve it and properly dispose of it. It doesn't belong near the surface. But there is no study of alternatives to stabilization for you to review or for the Department of Ecology decision makers to review, and that's a violation of the State Environmental Policy Act. And it's a serious one because really, although they say we're not foreclosing getting rid of the waste, they are really foreclosing getting rid of the waste if they grout the tunnel 3/8 of a mile long instead of stabilizing it externally or even grouting the first 100 feet. Thank you. Tom Carpenter, Hanford Challenge.
Thank you, Jerry. So thank you, Jerry. No. Okay. So it was an excellent presentation. Thank you, Ecology, for hosting this public hearing tonight. And we sure appreciate it. And we hope that the Energy Department takes notice that people are interested and will come out for these kind of meetings. And there's some other big decisions coming down the pike at us, which you can find out on the tables back there. Just a very few comments to add on to what Jerry just said, which is some of what is in these tunnels, even though it's not well characterized. We do know that it came from some processes and some buildings that generated essentially high-level waste. The 324 building that Alex Smith mentioned has German spent nuclear fuel in it. It's one of the big cleanup problems out there. And in fact, the radiation fields in this tunnel are so high that they're essentially lethal doses within minutes, which is why you can't send someone into these tunnels. And you know, that suggests that there is some really bad stuff in there, but not knowing what that is a real problem, because the law requires that, for instance, high-level nuclear waste be disposed of in a certain manner. That does not include concrete and shallow land burial. Does not. It has to be removed, treated, and put in a deep geological repository. Another example is plutonium. We don't know how much plutonium is in this waste, but it's a long-lived product. It will be around for 250,000 years. Shallow land burial in concrete is not an appropriate storage medium for that either. And there are laws about how much plutonium you can leave in shallow land burial, and I'll bet you that it would be violated if it was like that. So we are with everyone else on this one, which is to say, ecology really does need to require that this will be removed. Not just DOE says that someday it could use diamond wire saws and cut it up. The temptation is going to be overwhelming to say, it's in concrete, let's walk away, it's done. We got other fish to fry here out at Hanford, which is true. There's a lot of problems, but we can't let the economics of it be so tempting. So how do you get around that? You have an order, you have an enforceable agreement in the tri-party agreement that can be enforced down the road in a court of law. So that's what we're urging comments tonight to reflect. We're hoping that ecology listens to that. And you know, I think this is a done deal. I think this tunnel is going to get filled with concrete. And you might want to ask that question. I have heard that, you know, things like contracts have been let, et cetera. So I think it's coming down the pike at us. So what can we do from here? Thank you very much.